So you're looking at a cupola that's someplace between 18 and 20 foot tall. The top part of the spire in the church steeple actually has 8 sides to it. So there's actually 16 rafters up inside there. And it's the same way you'd build a church steeple if it was 30 by 30 on the steeple roof. But what I wanted you to see and have a concept of is that this cupola sits square on top of the barn. In other words, its sides are parallel with the sides of the building, and the sides are parallel with the ridge of the timber frame. Unlike the one that we're going to show off in our YouTube videos leading up to class this year, which is turned 45 degrees. We've built probably a good 12 to 15 very large cupolas since we began timber framing back in the mid-70s. Most of them average around 16 or 20 to 20 feet. But if you saw one of our barns, you'd never believe they were that big, because a properly proportioned cupola on the ground should appear to be huge, almost the size of a small outbuilding. And then when they get placed on top of the barn, the perspective totally changes and enhances the look of the barn. It makes everything appear bigger and taller and really sexy. Most of our cupolas have been placed on the ridge of a barn in a very traditional manner, meaning that this square embellishment, cupola as we may call it, with windows or louvers, sits with the sides parallel to the ridge on the building. I was overwhelmed with the idea to do something different, and so I decided to take the cupola and turn the cupola 45 degrees to the ridge, so it's no longer parallel with the ridge or the sides of the building. I want to give you a brief description of how I started. I made this rim first, this square piece at the top, which represents the square inside opening of where the base, the lower part of the cupola, joins to the main body of the cupola, which would be right here. It's a 3-component addition. It's the base, which is what we're talking about now, this diamond-shaped, tapered base. Then that's component 1. Component 2 is always the main body of the cupola, so the area where the windows would go or the louvers would go. And then component 3 will be the steeple roof. Now, right now I got it in my head, okay, this base is 4 feet tall here. So it's going to extend 4 feet up at the longest part of the roof that it intersects the roof. In my mind, the main body should be around 5 foot. So we already have 9 foot between the base and the main body. And I'm thinking to build the biggest church steeple style roof that we've ever done. I'm thinking of building a 16-foot tall steeple, a 25-foot tall cupola. I took the rim and I built that. Square, flat, and true. You want to make it out of white pine so it's lightweight, so it doesn't add weight to the roof. And then the first thing I did was attach these 4 adjusting blocks, if you will. I did 3 others, and we attached them in a pre-planned fashion to the roof model. Okay? As you can see, we have a roof model here, which mimics the actual barn that it's going to go on. That's how you build a big cupola. You don't get up on the building and build it on the roof. That's not practical. That's how they did it years ago. So we located these 4 leveling blocks at 4 equal quadrants on the roof. Then we cut 4 hypothetical levelers that could be adjusted up and down to set the height of the rim. I only had to set the height in one position. For instance, right here, I had to set the height. And then all we had to do was put a level and a straight edge, an 8-foot aluminum straight edge, and then we added this horizontal piece across the top here, which would have given us a level surface. And then I took this square rim, turned it 45 degrees to make it diamond shaped, and I was able to sit it on a level surface. We tapered the base about 6 inches, which just added to the complexity of this. So I'm going to show you how we tapered this base let me hold that level. Okay, it's plumb right there. And as you can see, that level is 6 or 7 inches from the base of the cupola. So we not only increase the difficulty of building it, but the drama and the look that this is going to have to be biased 45 degrees on a base that's tapered, you guys. Can you see it? Can you feel it? Every stud that we put in needs to be cut at a taper. What it also means is the ledger or the sill, the lower part of this base, has to be tapered also. Actually, diagonally down here, it's around 15 inches. But this goes from around 10 inches wide at the bottom. It tapers up, 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 up to about 5.5 inches at the top. So the studs of the base will actually follow this bottom ledger. So what we did was we plumbed the back of this rim here down to the roof model, okay? And we made that plumb mark down in several places. Then we took an aluminum straight edge and we drew the inside. So we actually had this diamond shape that the top rim represents. We transferred it down onto the roof model. The next thing I did was I took some pine 2x6s. I made angle cuts at the ends. They're compound angles. For instance, that cut right there is cut at an angle that's 35 degrees by 30 degrees. And this bottom cut is actually 47 degrees by 90 degrees. So I played around with some scrap wood on the chop saw and I identified the proper angle treatment for this bottom ledger at either end. So now I have this 2x6, which was a mirror image on the inside of this rim on the top. So then I started with a bevel square, you guys. This very handsome homemade bevel square, which is actually made of bird's eye maple, was made by a very dear friend of mine named David Smith. And what I did was I started up here and I started to look at the angles. You know right away that an angle like that is too steep. That doesn't look right. That even looks worse. So that's how I worked myself through it, you guys. And then what I did was I used the level to identify just how far back, how much it was tapered. So I was able to set the bevel square at 20 degrees. So once I did that, I was able to extend 20 degrees down and make a mark. And then I was able to follow this top ridge up again in the same fashion, and I was able to level it down. So now I had a beginning and an ending point. Once I figured one side out, the other 3 sides are typical. In other words, they just get built like this side. Anyway, I do hope that you'll follow us along on YouTube here as we construct this cupola. We're starting now a few weeks before Christmas, and my plan is to install this totally finished. We're going to put it up with a big crane in May over at the classroom, over at the barn in Wallingford, Connecticut. So I hope you'll stay tuned for more videos, and I hope you'll consider attending this year's Northford Timber Frame class, the class of 2012. It may seem a little bit out of character or out of sync that we're talking about an odd-shaped cupola, but hey, I want you to know we're about a lot more than just a lot more than timber framing. It's a whole complex mechanism of its own, and it takes a long time to understand the process and the layout. We want to help you with that. We want you to take our class, and we want you to learn how to build things like this. Thanks so much.